For question 40, it is actually mixing both trigonometric functions and transformation of curves. So I'm going to teach you two methods. Firstly, I'm going to teach method one, which is the transformation method, okay? So you can obtain from the graph, okay, given you the sign. Recall, what is the graph of y equals sine x? It should look like this, right? Okay, this is 90, all right? But now, it seems it is reflected because it goes down at first, but you can see it goes up at first. All right, so you can see reflected in negative here, right? Okay, and you can see it actually it is reducing to 1 over 2. You can see originally the turning point should be 90 degrees, but it starts turning at 45. So it's reduced to 1 over 2. All right, reduced to 1 over 2. How do we express in terms of a function? It should become negative sine 2x, right? Because reduced by 1 over 2 means inside it should be 2, okay? Recall the transformation of curve, okay? So reduced to 1 over 2, negative sine 2x, all right? So then also, originally in 0, it should be 0, right? In the original sine curve, but now in 0, it becomes 1, all right? So h is actually plus 1, okay? Because you move upwards by 1. You're translating the whole curve upward by 1 unit. So h should be equal to 1 and k should be equal to 2. And the answer should be D, all right? And I'm going to teach you the second method, which is the substituting point method, okay? Actually, you can use the method of substitution that, let's try whether y equals to negative 1 minus sine 1 over 2x is valid by substituting the point x equal to 45 and y equals 0. If the equation matches LHS equal to LHS, then it should be fine. Then the answer is correct, but it does not match, so A, B, C won't match. So you will only find that D matches, because when y equals to 1 minus sine 2x, you can know that 0 equals to 1 minus sine 2 times 45, 5 degrees. 1 minus sine 90, sine 90 is 1, okay? So 1 minus 1 equals to 0. So only D matches, okay? You can use both methods. You can obtain the same answer.